Okay, this is section 8.3 in your algebra chapter in your grade 9 textbook. This is questions 2 through 8 on utilizing distributive property in solving equations. So question 2 says Cal and Tiana solve the equation 3 multiplied by, I'm going to change it to x instead of k, minus 4.3 equals negative 2.7. They did it in two ways. Cal used distributive property first, where he would expand it like this. This is what Cal did. But Tiana used division first by dividing both sides by 3. Whose method do you prefer and why? So, in my opinion, if you understand this method here, and you get what you're doing, so instead of having, this really says 3 groups of this amount. So if I was to draw it, I would have an x and a minus 4.3. I'm going to put minus 4 and like a third, minus 4.3. And if I had 3 of those, I could take my infinite cloner, and I would have 1, 2, 3 of them. And when I looked at that, 3 groups of x minus 4.3, if I expanded it back in grade 8, you would say, well, I have 3 x's, and I have negative 12 here, and those negative thirds added together make another one that makes a third, makes negative 0.9, so I'd have negative 12.9, right? So if I expanded that, I could look at that and say I have 3 x's and I have 3 4 and a thirds, or 4.3s. But this way here, when you divide by 3, instead of having 3 groups of it over here, by dividing that side by 3, you simply have 1 group of it, okay? And that's what happens. When we divide a side by 3, instead of having 3 groups of x minus 4.3, we have 1 group of x minus 4.3 equal to, and again, we would divide that negative 2.7 by 3 to make it negative 0.9, right? So 1 group of x minus 4.3 would be equal to a third of what the other side was before. So if you understand that, if in grade 8 when you studied the 2 ways to solve distributive property, either through expansion or through division first, I would probably say the best way to do it would be to divide both sides by 3. But expansion, this idea of taking it and expanding by multiplying both terms in the binomial by 3, is still a method you still have to understand. But the preferred method would probably be the second one. Question 3 says Renee and Paul used a different method to solve this question. So they had x plus 1 over 2 equals 3/5. I'm just going to infinite clone this because it's going to save me a little bit of time here. So I'll just clone it, and I'll put it over here. Okay, so here's the 2 questions. And Renee, so this is Renee over here. Renee multiplied both sides by 10. He multiplied that side by 10, and he multiplied that side by 10. So again, this idea that if you multiply one side by 10 and the other side by 10, you maintain equality. And Paul rewrote it as half of x plus 1, because that's what it really is. You're taking x plus 1 and dividing it in half, or half of x plus 1 equals 3/5. So he wrote it like this, and then he was going to get rid of that, kind of thought of it as distributive property and got rid of the coefficient. So this idea of multiplying by 10, that came because he looked at the 2 terms in the equation, and they both had denominators in 2 and 5. The first multiple that 2 and 5 share was, of course, 10. So by multiplying by any multiple, the lowest happens to be the easiest, what you end up doing here is if you cross-reduce, you get a 5. And then 5 if I multiply the numerators, I'm multiplying 5 by x plus 1, which again, it doesn't look like it, but you need to utilize distributive property. So when I multiply that side by 10, I end up getting this. And when I multiply this side by 10, I end up getting this. So in Renee's method, by multiplying both sides by a common multiple of the denominators of all the terms in the entire equation, Renee created a simpler equation that in this case is actually a grade 7 algebraic equation, and I think everybody in this room can probably solve that one, I hope. In Paul's method, Paul decided to reinterpret half of x plus 1 as being a coefficient in distributive property. Here, we could divide both sides by a half. That would get rid of the multiply by a half. And when I divide by a half, that's really the same thing as multiplying by the reciprocal. So I'm actually going to change that to, instead of dividing by a half, I'm going to multiply by its reciprocal. And then I'm going to have one group of x plus 1 equals 6/5. I'm then going to subtract 1 from both sides, and I get my answer. So the question is, whose method do you prefer? Probably in my case, I would say that, again, Renee's method is the preferred choice, as long as you understand when you have, if you're good with fractions, you can utilize them any way you want. I probably, if this was my question, I would have done it a third way myself, and I didn't talk about it. I would have multiplied both sides by 2, right? Multiply that side by 2, multiply that side by 2. I get x plus 1 equals 6/5. I would have got it just by multiplying both sides by 2. So there's Renee, there's Paul, and then there's Mr. Mack. You can choose what method you like better. I like my method, but I also like Renee's method. In question 4, Victor and Eshani were solving the following problem together. It said a square, which we'll put these little lines to show that it is a square, has a side length of x plus 1. And the perimeter of the square is 18.6 units, whatever that happens to be. What is the value of x? So perimeter would be taking this side and adding it 4 times, because it's all the same length, or saying 4 multiplied by the side length equals its perimeter. So if I was setting it up, I'd say 4 sides equals the perimeter of a square. And since the side length is x plus 1, I would do it that way. So Victor did it that way. Whereas Ashani did it differently. She said the perimeter would therefore be 4x plus 1 equals 18.6. And what was the mistake is that this is not correct. Because when we say 4 sides of x plus 1, and we utilize distributive property and we expand it, the correct answer would be, this is the formula, not 1. So what she did is she multiplied the x by 4, but she forgot to multiply the second term by 4. Now we get into the nitty-gritty. Question 5 gives you a paper clip and a nickel. And it triples it. It takes this and it clones it 3 times. So we'll do infinite cloner here. So there's 2 of them, and there's 3 of them. And it says this is equal to, and then it gives you the picture of, what is that, 60 cents? 25 cents, 25 cents, and 10 cents, I think. This is the picture. So a paper clip and a nickel, and a paper clip and a nickel, and a paper clip and a nickel equals 60 cents. And it says write this as an equation. So it's really 3 groups of a paper clip and a nickel. 3 groups of a paper clip and a nickel is equal to 60 cents. All right? So then it says solve the equation. So really what we're solving here is what is the cost or the value of a paper clip. If a paper clip and a nickel tripled has the same value as 60 cents, how much is a paper clip? So again, we can do this question, and I'm going to just infinite clone this again. I'll clone here. I'll bring it over here, and we'll examine it 2 ways. So the first way I'll do by expansion. So 3 paper clips and 15 cents is equal to 60 cents. Subtract your 15 cents on both sides. You get 3 paper clips is equal to 45 cents. Divide both sides by 3, and I don't have room for it, so I'm going to put it up here. So therefore, each paper clip would be worth 15 cents. Okay, that's by expansion. Now, if you use that other method we talked about, division first, you would divide both sides by 3. So instead of 3 groups of paper clips, then that means that 1 group of a paper clip and a nickel is equal to 20 cents, right? Because I'm dividing both sides by 3. So it would look like this. A paper clip plus a nickel is equal to 20 cents. Subtract the nickel from both sides, and a paper clip is worth 15 cents. Both methods get you the answer. A paper clip is worth 15 cents, but you have to be aware that there is expansion to solve distributive property and division first. Okay, that's the key to that picture. Question 6 gives you 4 questions. Okay, so here are your 4 questions. Now, because you can either solve with expansion or division first, I'm going to do 2 of the questions using expansion and 2 of the questions using distributive property. So we'll start with distributive property here. If I expand this using distributive property, I'm going to get 2x's plus 3 equals 7.6. I get rid of my constant and have 2x equals 4.6. Divide both sides by 2 and x equals 2.3. That's utilizing expansion. I'm going to do division first here. I'm going to divide both sides by -1. One group of this is then equal to a positive 2.8. I'm going to add 65 cents to both sides, or 65 hundredths, excuse me. And C will equal 3.45. What are we going to do here? Let's use division first for this one. So I'm going to go dividing by 3 and dividing by 3. One group of A plus 4.51 instead of 3 groups of it is equal to 3.57 divided by 3, which is 1.19. So negative 1.19. Subtract 4.51 or subtract $4.51 to a debt of already, that is going to be 560, 570. Negative 5.7 equals A. And the last one, when I expand, I chose the wrong one to expand, but whatever. Negative 3.6 times a quarter, or a quarter of 3.6. Well, half would be 1.8. A quarter would be decimal 9, so negative 0.9 plus 3.6r. That's a positive because a negative 3.6 times a negative r is a positive 3.6r equals 18 hundredths. I'm going to add 9/10 to both sides. And a positive 3.6r, why did I put the positive symbol? That's superfluous. 3.6r equals 0.27. Divide both sides by your coefficient. Take your calculator, because I'm not smart in the least. 27 cents divided into piles of $3.60 is 0.075 equals R. So far, so good? Question number 8, your last one, correct? Okay, for these ones, again, we have these complicated, convoluted things here. I'm going to solve them in different ways. For this first one, you can multiply both sides by 4, but I'm just going to multiply both sides by 2. Okay, and by doing that, you probably see that multiplying by 2 and dividing by 2 leaves with a beautiful n plus 1 over here. And when I multiply this side by 2, I get negative 3 over 2, or negative 1.5. You can go negative 3 over 2 or negative 1.5. The next thing I'm going to do is subtract 1 from both sides, and n will equal negative 2.5. Okay, so I didn't make it overly complicated. I could have done it a few different ways, but I'm going to keep it that way. And as you approach questions, you can, as long as you have more than one way to approach the question, you can choose which way you did. That's a fairly easy way of doing it. Here, I'm going to divide both sides by a third. Since I'm multiplying by a third and dividing by a third, that's going to cancel it out. Remember, dividing by a third is the same thing as multiplying by the reciprocal, which is multiplying by 3. So since I'm going to divide this side by a third, I'm really going to take that 5 over 2 and multiply it by the reciprocal. Right? So over here we have one group of x minus 2 left because we multiplied both sides by a third. And over here, I'm going to get 15 over 2. And since I have a whole number here, I'm going to reconstitute that back into a 15 over 2 is going to be 7.5. I'm going to add 2 to both sides. And x is going to equal 9.5. Over here, I could expand it, but that would be ridiculous. I'm going to divide by 3/4 using my division first method. Dividing by 3/4 is the same thing as multiplying by 4/3. I'm going to multiply the side by 4/3 then. One group of W plus 2 is going to be equal to 16/9, or 1 7/9. Oopsie daisy. 1 7/9. And 1 7/9, take away 2, because I'm going to subtract 2 from both sides. W will equal negative 2/9. 1 7/9, take away 2. Now, if you can't do this in your head, change them into improper again. So you got 7, you got 16/9. Is that what I had before? I think so. Take away 2, which is 2 over 1, will be 16/9. Take away common denominator of 9. That'll be 18/9, right? 16/9 take away 2 is the same thing as 16 over 9. Take away 18 over 9. It's still negative 2/9. And the last question, which is looks like it's hard, but it's not that bad. Multiply both sides by 3. Multiply by 3. You get 21 over 6 equals 2 times 5 minus g. Right? By multiplying both sides by 3, I get that. I'm going to expand this time. I'm going to get 21 over 6 equals 10 minus 2g. I'm going to add 10 to both sides. Add 10 to both sides. Hold on. 21 over 6. If I add 10 to it, ooh, this is going to get complicated pretty quick. 10 is really the same thing as, oh heavens, 10 over 1 is the same thing as how many over 6? It's 66. It's the same thing as 10. Plus 21/6 is 81/6 equals negative 2g. Whew. Divide both sides by negative 2. 81/6 divided by negative 2 is the same thing as multiplying by the reciprocal of negative 2, which is multiplying by a half. You know, dividing by negative 2 is the same thing as multiplying by a negative half. That's going to be negative 81/12 equals g. 5, 6, 6. Negative 6, which is 72. And 9/12 equals g. Or negative 6 3/4 equals g. Those are a lot of work. Holy snap and Archibalds.